Greetings, junior scientists, and citizens of this great big weird wild and wonderful world in which we live. As always, I'm your humble science communicator, the Great Orbax, coming to you from the Department of Physics here at the University of Guelph. And I'd like to welcome you to our February 2025 Stargazing Guide. With the vernal equinox approaching in March, February marks our last full month of winter. And oh, what a winter it's been. But every day our daylight hours get longer, with sunrise moving from 7:37 a.m. on February 1st to 6:59 a.m. by month's end, and sunset going from 5:33 p.m. at the beginning of the month to 6:09 p.m. by the 28th, leaving us with more than 13 hours of dark skies to gaze into. And what should we look for? This month, the planetary parade persists. We learn what the term retrograde motion actually means, and we try to spot the snow moon through all this snow. All this and more when we just take some time to look up. Last month, we talked about the planetary alignment taking place in our skies and dispelled a few myths that you may have heard in the media. Now, while news outlets claim that January 21st was the best day for observing, you probably noticed that those planets are still there after sunset. We've been incredibly lucky to have Mars, Jupiter, Venus, and Saturn still visible to the unaided eye. And if you have access to a modest telescope, you may even be able to spot Uranus and Neptune. Now, starting mid-month, you'll be able to see Mercury following the sun down to the horizon. And it'll actually be visible near where the sun has just set for about 30 minutes after sunset by the end of the month. During that window, Mars, Jupiter, and Venus will also be visible in the sky, but Saturn will be making its way closer and closer to Mercury, eventually disappearing below the horizon until it returns just before dawn in April. So you've likely noticed that the planets move in our sky relative to the stars and constellations over the course of weeks and months. This makes sense, right? We see the sun rise and set every day along its path, and the moon travels consistently as well. Every once in a while, though, the planets will do something strange, and they'll actually reverse their direction of travel, appearing to move backwards. This is called retrograde motion. Retrograde just literally means backwards. So how does this happen, and why would a planet just suddenly start moving backwards? Well, technically, we call it apparent retrograde motion, because this is just an illusion that occurs due to our perspective here on Earth. Okay, if we picture the planets orbiting the sun, they all travel in the same direction, with the closer planets moving faster than the more distant ones. To use an analogy many have used before, and for good reason, picture a race on a circular racetrack. We're Earth, and our opponent is Mars, the planet of robots. And we've got the faster inside track. As we approach Mars, from our perspective, it appears to be moving forward. But as we get closer to it, it starts to slow down. And it even looks like it's moving backwards when we start to overtake it. That's apparent retrograde motion. Once we come around the bend and get far enough away from it, Mars appears to return to its original movement, again heading east in our sky. Now, apparent retrograde motion occurs for all of the planets in our solar system. Jupiter will end its retrograde motion on February 4th, and Mars returns to its regular motion on February 23rd. Now, you can imagine that before we understood the subtleties of orbital dynamics, a planet suddenly changing its path of motion in the sky might be seen as an omen of doom or chaos approaching, a myth which has persisted to this day in some cases. But fear not, junior scientists, there's no scientific evidence that apparent retrograde motion has any effect on you whatsoever. Our full moon this month is on February 12th. Settlers called this the snow moon, for obvious reasons. While the Mi'kmaq of the East Coast called this the snow blinding moon, or a Buganajit, marking the difficult weather often befalling this time of year, and in some stories referring to the low sun shining off the snow in the daytime hours. The Cree called the February full moon Kisipism, or the Great Moon, while the Ojibwe call it Makwagisis, the bear moon, referring to the time of year when bears have their cubs. Well, junior scientists, I know that I'm getting this month's stargazing guide later to you than normal. But do you want to know why? Last week, I was lucky enough to go to Hawaii. And while I was there, I made the journey up Mauna Kea. Mauna Kea is a dormant volcano, almost 14,000 feet above sea level. That's halfway up Everest.
All right, everybody, we did it. We drove to the summit of Mauna Kea. We're up here with the observatory arrays. And we're at almost 14,000 feet above sea level.
And it was there that I was able to visit the Mauna Kea observatories, where scientists from 11 different nations study exoplanets, supermassive black holes, and the origins of our universe, using 13 telescopes administered to by 10 independent, non-profit institutions. If you want to learn more about what they do, check out the link below. The skies that I saw in that protected portion of our planet were unlike any that I've seen in a long, long time. Layers upon layers of stars, nebulas and galaxies, and it was all there waiting for me to just take some time to look up. See you next month, junior scientists, and don't forget to have a science-tastic day. Special thanks to Royal City Science's own planetary geochemist, Dr. Glynis Perrett, for her help preparing our stargazing guide. And the Royal Astronomical Society of Canada